Good morning, everyone. Today we're going to continue our discussion on time series. So far, we have looked at an example. By the way, before we do that, make sure that the packages are loaded and we were using ASTSA. We learned how to load also the other packages like tidyverse, tidyquant. Now, since these have been already installed in your computers, just make sure that they're loaded. So the pacman load function allows us to load these packages. Okay, I'm going to run this. On your end, kindly do so. Make sure that ASTSA, uh, tidyverse, quant mode are all loaded, installed and loaded. And we learned that we only install once and then we load whenever we use the package. All right. I hope you got it. Kindly chat, please, if you are able to load already these packages so that we can all begin at the same time. Thank you. Thank you. So let's give the others a few more seconds to load the packages. Okay, good. All right. So just a friendly reminder for you to watch the videos on data types and data structure that will be included in your face-to-face exams together with introduction to time series. Okay, so let's proceed. uh, from the ASTSA package, if we take a look at your packages and type applied statistics for time series analysis here. Okay, it has already been checked here, clicked here, which means that the functionalities, the commands coming from ASTSA are already available for use. Okay, if I click this, you can see that this contains examples of time series data. All right, and one of them is the J&J data. This one. So this was what we were uh, we loaded last time. And then next we're going to look at Gtemp. If you once again take a look here, we have Gtemp both, Gtemp land and Gtemp ocean. So let's start first with J&J. So in order to access this data, we can make use of data and then put in quotes JJ, which is the name of the data. Sorry, class. Okay, so when you look at the environment here, this falls under values. Okay, so how do we access the data? We already have ready access to data. If you want to print it, just type either JJ or, as we said last time, print JJ. That's the same. Will give you the same answer. If you run JJ, it will give us a printout of the data. Okay, here. So it's earnings per share of Johnson & Johnson from 1960, quarterly data from 1960 to 1981. And we learned about this function, the view function, will allow us to see the data, at least the information about the data in is one of our tabs here, view, there. Okay, so it's telling us that the name of the object is JJ. It's a vector, double, which means it's numerical, 84 observations. It's a time series data. So here are the values. Okay. So we can check that here in our values here. JJ is a time series data, 84 observations. I'll just delete this. Okay. And then we can take a look at the structure of the objects, the STR. it gives us what we call metadata, data about the data. So it's a time series data, okay, 84 observations. All right, so you can see that any object that we created or access will be reflected here in your environment. Okay, then we plot this. We learned how to plot this. The base R function plot. You plot JJ. You don't need to put it in quotes because there's an object already existing by the name of JJ. So R will understand that. Type is equal to 0 and Y label is equal to the name of the Y-axis. And running this, we have this one. Okay. So you can see here the advantage of using an R Markdown file. Okay. All right, then let's have another example. This is data also coming from ASTSA. This is the average land ocean temperature index from 1850 to 2023. So they kept a record of it. Data are deviations measured in centigrade from 1951 to sorry. So it's an index actually, land ocean temperature index from 1850 to 2023. The data are deviations measured in degrees centigrade from 1951 to 1980 average. So they measured the deviations from 1951 to 1980 and then they got the average. Okay, so let's just get this first. So we can just identify this G-temp land. This will be recognized because ASTSA has already been loaded in your computers. Okay, there you go. And it automatically also prints the data, G-temp land. And if you check the environment, okay, why is it not appearing here? Okay, we haven't created yet. Okay, if we create this object, okay, so for example, let me do the regular way, data G temp land. Okay, just like the one a while ago, and then okay, run this. You notice that it creates now this object, unlike by just uh, directly typing the name of the object. Okay, there's a difference between using data and then just typing gtemp land. When we type gtemp land, it printed the, okay, let me run this again. It printed gtemp land here, the data, but it did not necessarily create an object called gtemp land. Creating this object gtemp land required that we access the data using the data function. Okay, I hope you got that, class. Okay. Okay, let me illustrate that again, class. Maybe you were quite confused with that. So let me remove gtemp land. Okay, RM stands for remove. We have this object gtemp land, and I'm going to remove this. Control Enter. You can see now that gtemp land is no longer uh, it's no longer quote unquote accessible. Okay. However, if you just type gtemp land, it will be accessed because it's available in ASTA. But if you want to create an object with that name, okay, then you'll have to get the data first and then maybe give it another name if you want, okay? So for this one, gtemp land, okay, notice it did not appear here in the values. However, it was printed. So it's a time series data, starting with 1850 and ending with 2023. Okay. Okay, then let's plot this using once again this one. Plot gtemp. Okay, I'll just plot this line. Okay. So gtemp plan, okay, it's from 1850 to 2023. Okay. All right. So you can see here that the global mean land temperature, uh, there has been a an increase since 1950. And this could be a reason why scientists are claiming that there's a there's a what we call global warming. Okay. Yes, Christian, you have a question?
Yes, sir. Yung sa data GTemp land, what if tinanggal niyo po yung second GTemp land?
Yeah.
Kunwari, what if you remove that one? What will happen po?
Which one? Which G template here?
Uh, ano po, the one under data GTemp land po. If you remove that, what will happen po?
uh, okay. Are you referring to this one?
Uh, the
Let's
one earlier po.
this one, this one.
Yes po. What if you remove po the one from the line 65? What if you remove that?
Wait, this object is actually not existing, no, here. It's not
Hmm.
in the values. This object is found in a package called ASTSA, so it's here.
Mhm.
So here, we just wanted to have it printed. Okay? Pinaprint lang natin. We just have wanted to have it printed, but it's not actually saved in memory in your file. To save a data in your memory, okay, you have to use data, access that data. So for example, here, you notice now that it's now available uh, as an object in your environment. It has been loaded to the memory. Ito hindi, no? So no point in deleting this one. Okay. So let me all right, let me show this another way. So we now have this object. Now let me create a new object called GL, gtemplan, alt minus. Okay. So what happens if I create so we have now gtemp land here, okay? I'm now creating a new object called GL, and GL is actually gtemp land also. So if I run this, control enter, notice that I now have another object called GL. And this GL is exactly the same as gtemp land, right?
Mhm.
Gtemp land. So I was able to create an object called GL and assign the data gtemp land to it because gtemp land was existing in the environment. Okay, okay,
Ah,
let me repeat the process, okay? I'll remove GL, okay? I'll
sir,
remove,
so,
sorry.
uh, sir, so the purpose po of writing GTemp land line 65 is to make sure that it gets becomes an object po sa values. Tama po ba?
That's 63. That's line
So this
63.
63
Yung 65, print lang yan, no?
print.
Kasi tignan nyo, ha? Notice, wala nang GTemp. Okay, I'll use another one. GTemp ocean. Ocean.
Sir, what do you mean po by print yung sa 65? Like, you
Just,
type it to the print.
yeah, it will be printed here in your script window.
It's just for the ano lang, script window lang, sir.
Yeah, for you to see what it contains.
Ah,
Okay, so for example, this one, GTemp ocean. Notice I did not use data. I'm just going to use gtemp ocean. This will be read by R because R knows that there's a data coming from ASTSA package named gtemp ocean. Okay, so if I run this, control enter. Okay, let me show you the environment window. Okay, let's see what happens if just like gtemp land, if I run this one, it just printed it. No? It printed it in the console. It printed what's inside this data, what's inside this object. it also printed it here. But it's not saved in your environment. Okay?
Ah,
It's not saved in your environment. Now, if I try to, let me create an object, okay, GO, gtemp ocean, alt minus, and gtemp ocean. Okay, let's see what happens. What will happen with this? Control Enter. Okay, what happened was R created this object GO, global. I just named it GO, and it's coming from gtemp ocean. Now take note, gtemp ocean is not existing. Okay, however, R knows what this is because ASTSA is loaded, and ASTSA has an object called gtemp ocean. Okay, this one. Where is that? Okay. Pero kanina ito, no, yung gtemp ocean na to, print lang to. Okay, but it was not saved as an object here. Now, naka-save na siya, no? Kasi may object na tayo na create called GO. Did that answer your question, Christian?
sir, actually medyo nalilito pa rin ako, but
Sige, sige.
I'll learn
Anong
try to learn as we go along na lang po.
sige, sige. Thank you. Sorry for the lack in the explanation. Pero ang ano lang dito, class, ang gusto lang natin malaman, okay? You can remove objects. You can remove objects. So ito, may gtemp ocean ba dito? Wala, no? So if I remove gtemp okay, ocean, okay, I'm going to remove it. Pero kasi wala namang gtemp ocean dito, di ba? So how can you remove something that's not saved in memory here? Okay, let me remove that rm. Okay, tingnan nyo. Object gtemp ocean not found. Kasi wala namang gtemp ocean dito, di ba? Pero if I remove go, okay, do we have go here? Yes. What's go? Go is actually gtemp ocean also. Okay, we told R to create this object GO, and GO is the data called gtemp ocean. Okay, but GO exists. And if I remove GO, okay, control enter, natanggal siya, na-remove siya. Unlike yung gtemp ocean na object, yan, RM, gtemp ocean. Ang sabi ni R, what's gtemp ocean? I don't recognize gtemp ocean. Although you had it printed here, di ba? You asked R to print gtemp ocean. So it was printed, the contents of gtemp ocean was printed, pero that object was not saved in memory. Print lang niya. Okay. What do you want me to do? We're telling R print gtemp ocean. Okay, I'm going to print it. Control enter. There. Okay. So if you just want to print the object, and then just type the object gtemp ocean. However, if you want to save it in memory, okay, kasi gagamitin mo pa later on, then create an object. Whether you use gtempplan, basta data, or give it a name. Yes, Christian.
Bale sir, yung sa line 63, the reason you type data is so that it loads the data from GTEM.
Exactly, and saves it here. Oh, and saves it
Sa
here.
pag-plot po sir ng sa ano po, sa parang diagram po. Tama po ba sir?
Sige, tingnan natin ha. May gtemp ocean ba tayo dito? Do we have gtemp ocean stored here? Hindi, di ba? Pero pag mag-plot tayo ng gtemp, okay. Alright. Ang question, will R be able to plot gtemp ocean? What do you think, class? Will R be able to plot gtemp ocean? Even if it's not yet not saved here. If you type plot class and then write gtemp, in fact, yung IntelliSense niya, it gives you an option. Gtemp both. Wala naman gtemp both here. Gtemp plan, there's no gtemp plan here. Or gtemp ocean. So if I choose Gtemp ocean, let's see if this will plot. Control enter. Okay, it plotted Gtemp ocean. Okay, so as to your question whether we use data in order for us to be able to plot it, not necessarily. Kasi even without Gtemp plan here, are plotted, diba? Are plotted Gtemp plan. Why? Why was it able to plot Gtemp plan even if it's not in memory here? Because it recognizes the Gtemp ocean because we loaded ASTSA. Now let's take a look at this. Okay, ASTSA. I'm going to unclick this. Okay, I'm going to detach this. Okay, so let's see. Let's run data Gtemp plan. Control enter. Notice what happens. Not found. Gtemp plan not found. Okay, if I have R have R print the data Gtemp ocean, control enter. Error. Gtemp ocean not found. Why? Because Gtemp land, Gtemp ocean, Gtemp both are all found in this package. Okay, ASTSA. So in order for you to access that date, those three data, you have to require this there. Okay, library ASTA. Now you can once again Gtemp. Okay. In fact, if you just type Gtemp, okay, Gtemp, it will already give you an option. Okay. Gtemp. R is guessing. Are you accessing Gtemp both land or ocean? Okay. It does now because ASTA is loaded. Let me remove this again. Okay. And type Gtemp. None. Even if I type the complete name, none. Why? Because R is not able to access this because ASTA is not loaded. Okay? So you use this data not only to print this one, okay? Not only to print that, but it's more of being able to access that. Okay? Because later on, you might be using some of the data in Gtemp land or Gtemp ocean for some statistical measures. Okay, and it's good for it to be readily available here in your environment. Okay, Christian, did that answer your question?
Yes, sir. Thank you.
Okay, all right. Thank you, Christian, for that question. All right, so we saw the difference between just naming the object or creating an object to represent that object. Okay, and whether you whether you create, for example, again going back here, Gtemp land. So, okay, oops, sorry, it's not yet loaded. ASTSA again, this one. So it's now available. Okay, and if I plot once again Gtemp land, it will plot that object. Okay, so this is an example of a time series data, and the objective here, our ultimate objective, is to be able to come up with a model, okay, which we can use in order to predict. If this is up to 2023, then one one exercise could be to predict the deviations in the global temperature, mean temperature, land temperature from 2024, for example, to 2020, 2 years, 3 years, etc. Okay, so R is very powerful as far as accessing the data. R comes with several packages that has many many data from different fields. Okay, so we can also get this. Actually, we did this already. So let me just run this whole code chunk, and what will happen is, okay, I don't have globe temp ocean yet. If I just plot this class, okay, it will plot Gtemp ocean. However, it will not create an object Gtemp ocean. Why? Because I did not create an object for Gtemp ocean using either data or giving it another name. Okay, just like what we did a while ago, the GO. Okay, if I click this, notice that it plotted G-temp ocean, but it did not create an object called globe, global temp ocean. Okay, let me pause for a while, class, and maybe I'd like to, may I have your feedback as to the discussion has been clear. And thank you, Christian, for that question. It helped it helped the discussion. Okay, may I have your feedback, please, if you're okay so far? Okay, thank you. Okay. Waiting for the others. So please don't be ashamed to ask questions. Okay, let's follow the example of Christian, who asked questions in order to clarify some things. Okay, that's good. Thank you. Okay, let's go here. And there's this other data, GTemp both for global and I mean for land and land and land and ocean. Okay. All right. So that that was just meant to show us examples of time series data. So we said that time series data is different from cross-sectional data. Cross-sectional data, I'm not sure if I discussed that with you, but however, let me make sure that all of you understand the distinction between cross-sectional. So the three main types of data could be cross-sectional data, time series data, and panel data. In case I'm not sure if I discussed this with you, because definitely I discussed this with FinArts, and we can distinguish it based on the number of units or individuals being studied and the time or the period is the period. I apologize for I lost my digital pen, can't find it. So I'm now left with a digital pad, which is useless because I don't have the pen. So I'm just using the mouse now. I apologize for that. For cross-sectional data class, you're looking at, okay, several units, many units, okay, and one period. Going back to the example, global, let's say global land temperature. Suppose what we did was we got the global temperature of many countries, let's say Asia, let's say just focus on Asia. So how many Asian countries are there? Depende, no? So actually I forgot already. So let's say there are, let's say 80 Asian countries, okay? Then what happens, class? It's cross-sectional data when you're looking at the global land temperature of this many countries in 2023. So you only have one period, okay? One period, but several units, so several individuals. On the other hand, for time series, you have one unit, one individual being considered, and many periods, okay? Same data, Philippines. You're looking at the global land temperature average of the Philippines from 1850 to 2023. How many periods? Many. Okay, time periods, many, from 1850 to 2023. How many units being considered? Just one, Philippines. Okay, so that's a time series data. Okay, time series data. And then panel data will be a combination of multiple units and multiple points in time. So same thing, Asia, okay, Asia, and then from 1850 to 2023. That's a panel data. Okay. In our case, class, our focus will be on time series. So we're focusing on one unit, okay, one individual being measured. That's actually what we call a univariate time series. Towards the end of this topic, we're going to be introduced to what we call multivariate time series. Okay, so let me delete that. Now, another example is speech data plots. So we're going to plot speech. We're going to label this is also coming from ASTSA. So they recorded the the phrase aha, okay, and they recorded the movement, I think, in this case. So let's plot this. Okay, aha, okay. Take note of the rising intonation 1,000 times. So this was recorded 1,000 times. And I don't know where the use of this maybe for linguistics, for studying voice or whatever. But this is an example of, well, this is actually a time series because there's 0.1 second uh, uh, what do you call that? I forget the term. Anyway, each 0.1 second, aha, aha, aha. So they recorded the movement of the voice. Okay. All right. Then another example is Dow Jones average. Okay. So this is daily returns for Dow Jones average from April 2006 to April 20, 2016. So that's an 11-year period. Okay. Let's plot this. Okay. All right. Okay, now let me introduce you to a very powerful package called Quant Mode. So let's go here first to packages and type Quant Mode. And since we have loaded this a while ago, it's already checked. But before we get before we learn the very powerful Quant Mode package, let's first take a look at what this is all about. So it's a quantitative financial modeling framework. So let's click this. And it's documentation for Quant Mode. And you can see here, we can check this out and see what this is all about. The description is a quantitative financial modeling and trading framework for R, designed to assist the quantitative trader in the development, testing, and deployment of statistically based trading models. Okay, rapid prototyping environment. All right, so authored by Jeffrey Ryan. So this is what this package is all about. Let's go back here. And you can see here so many, okay, so many functionalities. I think I mentioned to you before, for example, you can, on your time series data, let's say the returns of a particular asset, and you can add Bollinger Bands, you can add moving average, convergence, divergence, relative strength index. Okay, so many technical uh, uh, technical analysis metrics. Okay, so we'll learn first a very basic function. Okay, let me just first let's create a let's create a code chunk, and then let me use get symbols. Okay, so you can see if you type get, you'll have your get symbols lookup. Let's use get symbols. Okay, and then let's have a very basic object. You have to know the ticker symbol of the asset. So let's start first with Apple. This is the ticker symbol for Apple. So if we and take a look, class, at what will happen to your environment. Okay, and then let's run this, get symbols. Okay, there. You can see here that, okay, it generated this object, and then we can see here in your environment, an object was created. Now, this is not values. The values are vectors. This is an XTS object. okay, akin to a data frame. So that's why it's important for you to watch the videos. I hope you did, because most probably our exams will be first or second week, maybe second week of February. All right. So you have here, class, in your environment, Apple, okay, an XCS object. The start is 2007, January 3, and the ending is 2025, January 17. So that's the latest. Okay, because now it's January 20 in the US. January 17 is a Friday. No trading on 18 and 19. So this is the latest. This is the latest latest trading day data. So if I similar to the view a while ago, view, okay, capital V please, VIEW, and then type AAPL. So this will be recognized because there's already an object called Apple. Okay, so this one is the same as clicking this one. So let me click this one. If I click this one, okay, notice that it types here view Apple. And what do you have here? You have data, Apple data, the opening price, highest, lowest, intraday highest, lowest, closing price, the volume of stocks traded, and then the adjusted price. Okay, so you have 6 columns of data ranging from 2007, January 3, until the most current date of 2025. Okay, so with just one very basic code class, get symbols. Okay, if I want to, let's say, let's have another example, get symbols. Okay, and then let's do okay, C Meta and okay, Tesla. Okay, so we'd like to get the stock prices, stock information of Meta and Tesla. The source of this is Yahoo Finance. So Quant Mode accesses the data from Yahoo Finance and then saves it here. Let's see what happens when we do get symbols Meta and Tesla. Let me run this. Okay. And we now have here Meta and Tesla also. Okay. Meta and Tesla. Once again, I'm going to open Meta here. Meta. The date is different. Okay. Because this is the date when Meta was first traded in the stock exchange. Okay. May 18, 2012. How about Tesla? Tesla, on the other hand, 2010. Okay. June 29, 2010. But all of them have data until January 17. Tesla or Meta. Okay. All right. How about for Apple? Does this mean that Apple was listed on January 3? No, no. Every time in this year, 2025, every time you download or access data using get symbols, okay, if that stock has been listed prior to January 3, 2007, it will give your data starting with 2007. Okay, for example, Coke. Coke has been in existence before 2007, but when you get symbols Coke, it will also give 2007, 01, 03. Fast forward May, use get symbols again this year, it will still give you 2007 until the most current date of 2025. Okay. Next year, it will be 2008, most probably. Okay. Because it keeps on adjusting it by 1 year. All right. So you can see here that we have here XTS objects. Okay, so let's take a look at the. Let me just type it here. I'm going to to get the. Okay, create another code chunk. Control Alt I. Let's get the structure. Sorry, structure of AAPL. Okay. Remember, structure gives us information about your data. Okay, Control Enter. And we can see here that Apple is an XTS object. Okay, what does XTS mean? We're going to make use of this extensible time series. Okay, it's an extensible time series. The data is from January 3, 2007 until January 17, 2025. Data double once again, which means that the values there are numeric. They can take on decimal places, and 6 columns. Okay. Number of rows 4541. Number of columns is 6. What are the columns? Open, apple.open, apple.hi, etc. Now, what's the difference between for example, let's okay. Remember the pressure data set class? Let's get that data. Let me just illustrate the difference between the pressure data set. Okay, Control Enter. Okay, so we have pressure there. And let's view pressure. View pressure. Okay, Control Enter. So you have pressure here. Let's take a look at the structure of pressure. STR, pressure. Please chat, please tell me, class, if I'm going too fast, okay? Because this is just actually a review. That data set pressure, structure of pressure. Notice that it's a data frame, okay? For Apple, it's not a data frame, it's an XTS object, okay? And there's a difference between an extensible time series object and a data frame. Take a look at your pressure data frame. Okay, can anyone tell me what's the difference between that data frame and your extensible time series? Anyone, please? Aside from the fact that, of course, they have different columns, what do you notice? Anyone? Pressure, Meta, or Tesla, or Apple. Pressure. What do you notice about the difference between the two data set class? Yes, Christian, yes, please.
Sir, yung sa extensive time series, marami po silang columns. Tapos
Okay.
sa structure ng pressure, dalawa lang po siya, which is the temperature and the pressure.
Okay, yeah, that's correct, no? But of course, you can have another data set where you have 20 columns. So that will have 20 columns and it will be more than Meta or Apple. Okay, so, all right, that's true. As I mentioned a while ago also that aside from the number of columns and also aside from the number of observations, because pressure has only 19 entries, while Meta has 3,186. Apple has 4,541. But the main difference is that, look at the index class. This is the index. Sorry. Yeah, you were raising your hand, please. I'm sorry. Who was raising her
Ako po.
hand? Yeah, sige, please.
Answer lang po.
Yeah, Kate, sige, Kate, please.
Yung data frame po is just basically parang naka-table purpose lang po siya.
Okay,
Can store any type of data po. Pero pagdating naman po sa XTS, it is specifically about a time-based indices po. Kasi it's about stocks po, yung open and high. And
okay.
may time po.
All right, thank you. Yeah, that's true, Kate, no? And that's true, class. However, let me just clarify that an XTS object can also take on a non-quantitative number, data. Pwede rin yan, no? Pwede rin non-quantitative yan. Si pressure naman, ganun din, pwedeng quantitative at saka qualitative or character. Both of them can take on this, these types of data. The main difference is that take a look at the index class. Ang index nito, yung chronological 1, 2, up to 19 here, while dito sa time series na to, sa extensible time series, okay, take a look, class. The index is the date. Yun. That's the main difference between an XTS object and a data frame. And you know, this is very, very helpful. Kasi it's really so difficult. Imagine if this date was a part of this column here. Kunyari, date dito. O kaya time, whatever. Kasi it's difficult really to work with dates and times. The advantage of an XTS object is that the index was placed, the date was placed as an index. So you don't have to worry about, about navigating through this index. Okay, so this makes working with time series a lot easier, okay, a lot efficient. Okay, so using an XTS object for a time series is really, really very convenient compared that with a data frame. Okay, so yun ang main difference nila, no? And if you take a look, again, let's go here. Anong sabi dito sa some information about yung structure nito? Yan. Okay. So there are 6 columns: opening, high, low, close, volume, and yung adjusted price. Okay. The index, ito klaso, index is the date. 4,400, 4541 rows of dates. Okay. Time zone is Universal Time Convention. Okay. Ito dating GMT. Okay. Universal Time Convention. Okay. XTS attributes. Okay. The source comes from Yahoo. Okay. So this is coming from Yahoo Finance. Whereas before class, whenever you would want to get, maybe in your other subjects, you were tasked to download prices either from NASDAQ or Dow Jones. Okay. And then you had to use Yahoo Finance. Before you can use Google Finance, but it's no longer available. So you use Yahoo Finance, and then you can download stock prices there. Okay. Here with just a very simple code, get symbols. Then you're able to get the prices. Of course, you can adjust the date. What if I want the stock prices from 1980? So if the company has that record, then you can adjust the get symbols function. Okay. All right. So here you have POSIX CT. POSIX CT is a type of is a kind of time frame class which can accommodate, this is the year, month, day, hours, minutes, seconds. So POSIX is a powerful type of data because it can accommodate even to the nearest seconds. So this is even used for trading, intraday trading. Okay, where you account for the hours, the minutes, and the seconds. All right, so that's the structure of your XTS object. Okay, now let's go here. Okay, we're interested in getting, did I give this to you, class? Yes or no? Did I give that code to you?
Wala pa po, sir.
No, because I want you to write it. Huh? Okay? I purposely did not give that to you because I want you to experience on your own. Okay? So what are we doing here? DJIA. We're creating this object called DJIA. And then this is the assignment operator, alt minus class, the shortcut, or option minus for Mac users. And then the function is quant mode. And the package is quant mode, and then get symbols. So technically, you can just remove this. Okay? Okay, I'm just using this in order to remind you that get symbols comes from the package quant mode. All right. So let's take a look at this code. Now, I'm insisting that this is a ticker symbol for Dow Jones Industrial Average, caret DJI, okay? From, I'm telling R to give me data from 2006, April 2020 until to 2016, 04, 20. So that's an 11-year average, 11-year data set. And then you have this function, periodicity. The one good thing with quant mode get symbols is that you can make it monthly data, weekly data. You can do that. Okay. And then there's this function auto.assign is equal to false. I'll explain this one in a while. In the meantime, class, I want you to run this and check if it created an object inside your data. You should be creating this object DJIA. And what's inside is data coming from Dow Jones Industrial Average. Okay, so let me give you a few seconds to do that. When you're done, kindly please chat yes. Okay, good. Thank you, Christian. How about the others, please? When you're done, class, kindly please chat in the chat box. Good. Okay, thank you. Let's give your classmates a few more seconds. Okay, good. All right. So let me run it also. And now there is no DJIA here. But if I run this, okay, notice I'm creating an object called DJIA. What's inside DJIA? What's inside here? Which is get symbols. This is the ticker symbol for Dow Jones Industrial Average. You have the caret there, caret. No? And then I specify the date from to. And then the frequency of the data, I specify daily. And then auto.assign is equal to false. Okay, I'll explain this in a while. Run this, and you can see now, finished here. DJIA, view this, click here, same as view. So I have here 2006 0420, okay? And then until 2016 0419, okay? So apparently there was no 20. So most probably 12, 13, 14, 15, 16, 17, 18, 19. I don't know why there was no 20. Okay, maybe a holiday or whatever. All right, so we have here open, high, low, close, volume, the number of stocks traded, and also adjusted price. So we now have DJIA. Okay, let me just explain to you. Notice that the name is not DJI, but DJIA, because that's what we use. Okay, that's what we use. Now, so that explains this one, class. Here in the other codes that we wrote, okay, we did not write auto.assign is equal to false. The default is auto.assign is equal to true. And what does it do? Either if you don't if you don't, okay. Yeah, sure. If you have questions, okay. So auto.assign is equal to false, okay. So that means that you're not letting R give the name to the object. You notice here, class, get symbols apple, okay. And the default here is auto.assign is equal to true. That's the default. Even if you don't put auto.assign is equal to true there, is equal to T, then what will happen is that R will assign automatically the name of the object. So when we run this class, the default of R is to give a name to the object, the same name as the ticker symbol. Kaya nga, AAPL din. Meta also has the same name, Meta. Tesla also has the same name. If you want to give, for example, okay, let me create this object, Tesla. Okay, and then get symbols. Here, what I'm doing is I want R to give the name small TSLA to Tesla instead of this capital TSA. But I have to put here auto dot assign is equal to false. Okay. If I don't do this class, R will automatically name the object as TSLA. So let me put one here, for example. So we're getting the same stock prices. We're not defining the from and to. We're just downloading Tesla and just giving it a name, Tesla 1. Okay. So if I run this, control enter, take note what happens here. There's an object here, Tesla 1. Okay. And it's actually the same as Tesla. Exactly the same, but different name. Okay. So if you want to name an object differently, aside from the ticker symbol, then you can do that by using auto.assign is equal to false. Otherwise, if I don't, let's say I didn't put this one. Okay. What will happen here? I'm giving it a name, Tesla. Let me call this 2. Tesla 2. And then get symbols Tesla. So the default of this is auto.assign is equal to true. Okay. So it will create, let me remove for illustration purposes. Let me remove first Tesla, RM, TSLA. So I remove Tesla. So Tesla no longer exists here. And I'm going to get symbols Tesla. However, I'm naming it Tesla 2. However, I did not put auto.assign. Okay. Auto.assign is equal to false. So it will still auto-assign it to Tesla. What will happen to this one? Okay, let's see. Control enter. Okay, notice now that the Tesla name, Tesla object went back. Okay. And it's an XS object. What happened to Tesla 2? Okay. Tesla 2, an object Tesla 2 was created. However, it's only values. It's a vector only containing the word Tesla. Okay. So it does not represent that XS object for Tesla. Okay. So I hope that that's clear. So very important, yung auto.assign is equal to false, or is equal to true. Here, the object that was created is this one. Okay. Because we made it auto.assign is equal to false. Now, of course, you can you can change this. Okay. Make it, let me copy this class. Control C, Control V. I'll call this underscore M. Okay. Sorry. And for, let's call this monthly. Okay. Make it months. Okay. So I'm creating an object called DJIA month. Okay. The periodicity of this object is monthly. All right. So let me click this. Okay. Take a look at that, guys. TJI month here. And if I view this, Okay. So what's this? May 1, June 1, July 1, August 1, etc. And only 120 entries. Okay, as compared to the DJI here, which is daily, and had 2,517 objects. All right, let me pause for a while and ask you, so far, are we clear? Okay, feedback, please, if we're clear so far. Okay, good, thank you. So let's wait for the feedback of others. Okay, thank you so much. I hope the others are able to follow. All right, so, okay. So maybe I'll discuss this quickly, Control Alt I, because this is very important. Okay, so I want you to write this, class. I don't want to give this to you. What are we doing here, class? We're creating an object called DJIAR. And you notice, class, that I'm now appending a function to it. Diff log DJIA and then $sign here. Okay, so you type first diff and then log, and then if you type DJIA and then type $, you'll notice that it will open the columns inside DJIA. Okay, so let's use closing tab. Okay, all right, so what will happen here? This code, class, will get first the log of DJIA close. So where's the log? Where's close? So this is the closing prices, right? And then it will get the logarithm of this. Okay, for example, this is, get the latest date. Here, closing. Control C. If I get the log, Control V. Okay, the log. So the log of this is 9.8011. Okay, let's also get the log of the next one. Control C. Control V. All right, I'm getting the log also of April 18. Okay, control. All right. So the log of this one is 9.8. The log of this one is 9.7. And then if I get the difference of that, so this will be equal to difference of the one on April 19 minus April, Control C, 18. The log of this one minus the log of this one. So what do we get? So that's, oops, sorry. My bad. Why did I put equal here? Control Enter. There, it's 0.002 or 0.27%. 0.27%. Okay, going back here, class. It's almost time. Going back here. All right, so let's run this, class. Let's run this. So it will, what will it do? What will it do? It will get all the logs of each of the closing price, and then it will get the difference. Latest date minus earliest date, the day to day minus the log yesterday. So let's run this, and I now have here DJIAR. If I access this, okay. Now, let's see here, yung first date dito. Here, class, we got 0.2.002742, 2.7442, right? The same, class. This was the difference ng log on April 19 and April 18. Yeah, we got it correct. Okay, I hope you're getting me, class. And then notice, class, that it has an NA value here. So why NA? Because this one, class, this one, the first date, okay, you can get the log of this, but there's no April 19, right? So you can get the log of April 19 because it's not available. So you can subtract it. Therefore, it generated this one, NA. Now, what's the problem with that, class? Okay, I want you now to just insert here, maybe another one, Control-Alt-I, and then let's get the mean of DJIAR. Okay, get the mean of that, class. Okay, I hope you allow me a few seconds of extension. It's almost time. Control-Enter. Okay, notice that the answer is NA. Why is the answer NA, class? Why? Because there's a missing value here. Whenever your data has missing value, automatically R will return not applicable or error because you have to address that first. Okay, so what do we do? I'm going to DJIAR. I'm going to, okay, to subset this, -1. This means that I'm going to remove the first element. The first element here is NA. All right, so I'm going to create DJIAR. This time it will delete the first row. Control-Enter. Okay, and take note now, DJIA. Oops, sorry. Let me print DJIAR. What happened? Why did it not? Did I use a different one? Sorry. DJIAR, I should have done this. Okay, I'm creating this now, an object DJIAR. Then this DJIAR should be DJIA, but delete the first element. So Control-Enter. Now my new DJIAR has no NA here. And lastly, class, if I get the mean, Control-C, Control-V here, if I get the mean of DJIAR, it will now give us the average of DJIAR. Okay, it gave us the average because the new DJIAR does not have the NA value. Okay, so let's end there, class. Thank you so much. We're going to continue with this next meeting as we move on towards doing modeling, ARIMA modeling. So the last portion here is all about ARIMA already. So we're going to that portion already. All right, any questions, class?